Thank you. Okay, I will start. Good afternoon, everyone. My name is Phasit Petisiwaveth. I'm from Department of Radiological Technologies, Faculty of Medical Technologies, Mahidol Universities. Today, I'm going to present the research project in the topic of development of liquid dosimeters using polyvinyl alcohol and silver nitrate for food irradiations. Okay, first of all, I think everyone might be familiar with these green symbols. Yes, this is the food irradiation symbols, which is one of the food market trend for nowadays. Food irradiation is one of the modern food preservation and processing technologies that can improve the safety, extend the shelf life, or even enhance the quality of food at the same time. The ability to preventing the food with the minimum interruption to the functionals, nutritionals, and sensory made the food irradiation technologies become one of the most powerful methods for food preservation. However, the effectiveness of food irradiation is depend on the radiation dose, because if the amount of the radiation dose is too low, it cannot provide the technical purpose of the food irradiation process. And if the radiation is too high, it can destroy the structure of the food that can affect the functional properties, sensories, or even nutritional of the food. So, in order to reach the goal of the food irradiation technologies, the amount of the radiation dose must be controlled. That's why the radiation dose limiter is play an important role in these technologies. The purpose of the radiation dosimeter is to measure or evaluate the amount of the radiation in order to avoid the over or under exposure during the food irradiation process. And nowadays, the radiation dosimeter that apply in food irradiation is include perspex box, radiographic film, alanine dosimeters, full surface solution or freaky solution that we use as a routine dosimeters. But unfortunately, some of this method is not proper for the food irradiation measurements. It's because some of these are low in sensitivities, low dynamic range of dose, contain a toxic chemical that we don't want to contaminate with our food, and require a complex measurement process. So to solve this kind of problems, the extensive research has been undertaken to develop a novel, reliable, and practical dosimeter for food irradiation. The effort to develop a new dosimeter involved in many materials, for example, the optical fiber materials, the fluorometric materials, or even the nanoparticles materials. And nowadays, the research are focusing on the development of the nanoparticle material as a radiation dosimeters. I will tell you why. The reason is because it provides a highly stable, harmless, and environmentally friendly. This kind of material is based on the radiolytic synthesis of nanoparticles when using the gamma radiations. The amount of the nanoparticle mostly relate to the amount of the radiations, as you can see from the pictures. The amount of the silver nanoparticle is increased as the radiation increasing. From these principles, it shows that the proper possibilities to develop the nanoparticle materials as a radiation dosimeters. So the objective of this study is to develop a novel and reliable practical gamma ray dosimeters based on polyvinyl alcohol and silver nitrate for food irradiation dosimeters. Okay, I will start with the material and method. In this work, we developed the liquid dosimeter by using polyvinyl alcohol and silver nitrate. Firstly, we prepare 5% of PVA solution by dissolving 5 grams of PVA powders in 95 milliliters of the ionizing waters and continue stirring at 90 degrees Celsius about 3 hours. After cooling down, freshly prepared of full concentration of silver nitrate were added to PVA solution with ratio of 9:1. And then solution were mixed together for 2 hours to forming PVA-AG liquid dosimeters. After that, the liquid dosimeter was electrocuted to the radiation with the gamma cell 220 XL irradiators. The absorption spectra were analyzed by using the lambda 650 UV spectrophotometer in the length of 350 up to 800 nanometers. Okay, I will show you the results. In this study, we use full concentration of silver nitrate, which is 0.01, 0.11, and 3 molars. You can see that the initial color of the liquid dosimeter is different due to the concentration. However, after we irradiate the liquid dosimeter to the gamma ray, the color of every concentration is changed from the initial. But the interesting thing is the point of the color changing is different in each concentration. For example, the color of 0.01 molar is start to change from the color red to yellow at 80 gray, while 0.1 molar is start to change from color red to dark yellow at 40 gray. 1 molar is start to change from the dark yellow to yellow at 20 gray. And the last one, 3 molar, is start to change from the brown to dark brown at 10 gray. This result shows that the concentration of silver nitrate is affected directly to the sensitivity of the liquid dosimeters that we can estimate by our naked eyes. So to get more detail, the absorption spectra of the liquid dosimeter will perform both before and after irradiation process. The results show that after irradiation, the absorption spectra show the main peak around 402 nanometers. This peak confirmed the formation of silver nanoparticle after irradiation process. Moreover, the intensity of the absorption spectra is increased as the radiation increases. This pattern of the absorption spectra appears the same for every concentration. However, they are a little bit different for higher concentrations. The absorption intensity of the higher concentration seems to be saturated when irradiated to higher radiation dose. The result in this result show in the no changing of the color with the higher radiation for higher concentrations. So to estimate the changing of the intensity of the irradiation process, the dose response curve will plot as a function of absorption intensity to the radiation dose at the main peak of the absorption spectra. Okay. After we plot the dose response curve for every concentration, the results show that they are different in shape of the dose response curve. For example, the dose response curve show a sigmoidal behavior for 0.01 and 0.1 molars, while it shows the linear with saturation behaviors for 1 and 3 molars. However, to use as a radiation dosimeters, what we are looking for is the linear relation of the intensities and the radiation dose. So from the graph, if we take a look at each concentration, they have a linear relation, but in the different range of dose. So from the results, we can conclude that they are one specific range of dose that proper for use for one concentration. Okay, I will go to the detail. For 0.01 molars, if we draw a trend line, it will show the linear relation in the range of 40 gray up to 1200 gray with R square equal to 0.9796. And for 0.1 molars, the linear relation show between 2 up to 800 gray with R square equal to 0.9796. For 1 molar, the linear relation show between 2 up to 200 gray with R square equal to 0.9988. And the last one for 3 molars, the linear relation show between 0 up to 100 gray with R square equal to 0.9992. From this result, we know that for 0.01 molar, it proper to use as a radiation dosimeters in the range of 40 to 1200 gray, while 0.1 molar is good for use as a radiation dosimeter in the range of 2 up to 800 gray. And for 1 molar, the radiation dosimeter is good for use as the radiation dosimeter in the range of 2 up
to 3 minutes remaining. Go on.
And the last one, 3 molar is suited for 0 up to 100 gray. From this result, we can conclude that the concentration of silver nitrate can affect directly to the dynamic range of the radiation dosimeters. So in order to provide a large dynamic range of dose, the use of multi-concentration is needed for this kind of the liquid dosimeters. In conclusions, from the study, we can conclude that the concentration of silver nitrate in PVA-AG liquid dosimeters can directly affect both sensitivities and dynamic range of dose for this kind of dosimetries. And the use of multi-concentration can provide a larger dynamic range of dose that can start from 0 up to 1,200 gray. From all of the results, it can show that this PVA-AG liquid dosimeters has a high potential to use as an alternative radiation dosimeters. Okay. Before I say goodbye, I want to thank for Mahidol University that provide me all support for this project, and also Langsit Universities that provide me these huge opportunities for sharing my research. Thank you.
Okay, thank you very much for your good presentation. And from now is the time for the question. Is there any question?
No, there are not any question.
Okay, okay, all participants is no any question. Okay, so for me, my question is so now you study the effect adjust the concentration of the silver nitrate, right?
Yes.
And how about your opinion, another effect?
There are another effect. For example, the pH values can affect to the sensitivity of the dosimeter and also temperatures.
So that's all. Because so now I just want to know which effect is the major, because now you give the information range, the range of the dose range, right? If we adjust the concentration. So that's all must be better study, right, in your work.
This is just the beginning of the studies. Yes.
Okay, and so your liquid dose method, you use the polyvinyl alcohol, right?
Yes.
What is your reason why you use it?
Because polyvinyl alcohol is biocompatible. One of the reasons that we want to develop the dosimeter is we want the environmental friendly, and we don't want the toxicity of the dosimeters. That's why we select the polyvinyl alcohol that is environmental friendly and biocompatible. Yes.
And is this novel for this the liquid dosimeter? If you tried to compare with another research?
I try to use this kind of the dosimeter to compare with the standard one, to check the accuracy of the dosimeters.
And how is it? The compare with the standard one.
Okay, when we compare the standard one, it shows that there are no difference between the accuracy of the dosimeters. However, the appearance that show from this dosimeter, the color changing can notice more than the standard one.
Yeah.
The changing of the color from this kind of liquid dosimeter, it change at the lower dosimeters more than the standard one. So we can notice from our naked eye for this kind of liquid dosimeters. Yes.
So that's all of the reason. Okay, for me, I have no question from now. Okay, if no any question. Okay, so thank you very much, Mr. Phasit, for your good presentation and give the good answer. Thank you very much.